All right, last example says use Simpson's rule to evaluate this integral with n equals 10 and n equals 20 and use a spreadsheet to do the calculation. So let's do n equals 10 first. If n equals 10, our delta x is going to be, we're only going from 4 to 6. So it's going to be 6 minus 4 over 10. So that's 2 over 10, or 0.2. Our delta x over 3 then is going to be 2 over 30, or 1 over 15. All right. Let's see, our x sub 0 is supposed to be 4, and our x sub 10 is supposed to be 6. I'm only writing those down because I want to be able to check them when we put it into the spreadsheet. All right, so for spreadsheet, I'm going to put in all my stuff here. I'm going to put in my I, make a column for my xi's, then a problem for my f of x sub i's, and then my multipliers. So my i's, we're supposed to have, well, we've got 10 rectangles, so we start at 0, and we should go up to 10. Now my xi's, those are my x values. The first one we saw over here is 4, so I'm going to put that one in manually. And then the rest of these, we'll get them by taking the previous one and adding the width, which is 0.2. So if I copy this and I paste it down, this last number should be 6 because that's my that's where we're going to up here. All right, so now I've got to type in the function. Let's see, we got to do ln. I'm not sure how to do ln on the spreadsheet here. Let's experiment just a little bit. I'm just going to come over here, equals ln of 2. Okay, it looks like just ln will work. Just to verify that though, equals ln of, let's type in e. That should give us, should give us 1 essentially. So ln is correct. So equals ln of x cubed, so this guy to the third power plus 2. It gives us that. So I'll paste that down. My multipliers here are going to be 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. So let's multiply these together. I'm going to paste this down, and the sum of these guys is that. And so the integral, I'll type it next to it. The integral is approximately this 144 times, let's see, our delta over 3 was 1 over 15. So 9.65. All right. So that's it for the first part of this. Whoops. So for n equals 10, we get the integral is approximately 9.65055584. And I think that's what our book calls S sub 10, using Simpson's rule with 10 subdivisions. Okay, let's do it with 20 now. Let's see, with 20, our delta x is going to be 6 minus 4 over 20. So that's 2 over 20, or 1/10, or 0.1. And our delta x over 3 is going to be 1 over 30. So let's just go back to the spreadsheet and put this in again. Let's see. Rather than retyping all this stuff, I'm going to reuse what I've got here. Let's see. Okay, we're still starting at 4, but this right here is going to change. Well, let's see here, instead of going up to 10, we need to go to 20. All right, and these, instead of adding on 0.2 every time, we need to add on 0.1. So I'm going to take this and copy it down. And sure enough, we get up to 6, and we're going in increments here of 0.1. Now this, I don't really have to change, because this is just taking the natural log of this cubed plus 2. So I just need to copy the formula the rest of the way down here. And my multipliers, they're still correct, except for here I need to change this to a 2. Go down until I get to the end, make the last one a 1. Delete those. Copy these down. All right, now I'm going to do the sum of these 20 numbers. Gives me 289. And now, for my approximate integral, I need to multiply that by 1 over 30. So I'll take this, I'll make this equal to 1 over 30 times this number. I'm sorry, you can't see that. Let me scroll down. Yeah. So on that, I get 9.65. So let's see, this is S20. 9.650525931. So if you compare these two approximations, they're both good. I mean, 9.650525, and then they differ after that. Chances are that would be plenty of significant figures for you. But just for fun, let's put it in Desmos and see what Desmos says. If I put Desmos on here and I integrate, let's see, what was it, from 4 to 6 of ln of x cubed plus 2, it gives me this, 9.65052595. So I don't know what Desmos is using. My guess would be it probably uses Simpson's rule, and I don't know. My guess would be Simpson's rule and a bunch of subintervals. I'm not sure how many. But anyway, both of these are good approximations. And this is the kind of thing that you'll see in the homework is using Simpson's rule to do some evaluations. And I would suggest doing all of it with the spreadsheet.